All right, y'all, this is note card 33, finding extrema using critical numbers. Okay, so what we're really talking about here are relative extrema. All right, now before we kind of go over this, I want to give you graphically what we're talking about. All right, so if we have some curve, okay, I just want you to think about that curve for a second. Now the curve's definitely continuous everywhere. I drew that curve without picking up my writing utensil. So you think about certain points in this graph. Okay, let's think about a couple of these points. At this point, if I drew in a tangent line, all right, the tangent line would have a slope of 0. So this is a relative max. Okay, so at relative maximums, this is a critical point. Okay, why? Because f prime would equal 0. Okay, now here, this is a cusp. And what do you know at cusps, f prime is undefined. All right, so that would also be a critical value. Okay, here, this is a relative min. So at this relative min, f prime is going to equal 0. So this is also a critical point. What do you notice here? This is a hard corner. Okay, there's a hard corner right there. So at hard corners, the derivative is undefined. That's also a critical point. All right, here you have another relative min. So this would be a critical point or critical value. All right, here you get a vertical tangent. So at vertical tangents, f prime is undefined. So it's a critical value or critical point. And here you have another relative max. So f prime equals 0 there. And this is also a critical point. So just on the graph I drew, I know I kind of drew it complicated, but there's 7 critical values in that graph. So what's a critical value? A critical value, okay, is where, or I should say the x value, where the derivative equals 0 or the derivative is undefined. Okay. All right. And what we know here, if we think about this one, this point, this point, this point, and this point, if you notice, all of those points I circled in red are actually relative maxes or mins. So all relative maxes or mins occur at critical values. Now some of the other critical values, the other 4, aren't actually relative maxes or mins, okay, or they're not high points and low points necessarily in the graph, okay, but we know that those 4 are, okay. So relative maxes and mins always happen at critical values. So let's read some of these notes here. All right. So here it's saying if the derivative equals 0 or if f prime is undefined, then c is a critical number. To find the critical point, find the y value of the function at c or f of c. Okay. So to find the extrema of f, find the critical numbers, evaluate f at each critical number, evaluate f at each endpoint, and the least y value equals the min and the greatest y value equals the max. So we're going to do some examples. Okay. Number 1. It says if the derivative equals this, how many critical values does f have on the open interval between 0 to 10? Okay, so I'm just going to do this on a piece of paper. And I'm also going to use my calculator on it. Okay. So here's what it says. F prime of x equals cosine squared of x over x minus 1/5. Okay. I'm going to use a calculator. Okay. So before I do that, let me get a common denominator here. Okay, so let me put a 5 in front of there and a 5 in front of there. Let me put an x there and an x there. So if I wanted to rewrite this derivative, I could write it as 5 cosine squared of x minus 1 all over 5x. Okay? So what I have to figure out is for what values of x will f prime of x equals 0 or f prime of x is undefined. Okay. So I'm going to do part of this using algebra, and I'm going to do part of it using the calculator. Okay. So if I want to think about this function, where is this will be undefined when the denominator equals 0, because you know you're not allowed to divide by 0. So what that leads me to say is if 5x equals 0, then f prime is undefined. So if I divide both sides by 5, x equals 0 is one possible critical value. So that's a possible critical value. Now, is that in the interval they actually gave us? The interval they're looking at is 0 to 10. But the 0 here is a parenthesis, which means we don't include 0. So we can get rid of that. Even though 0 is a critical value, it's not in the interval. It's not in the open interval. If it was a closed interval, then yeah, it would be part of it. Okay, so what else? Where is this thing? Let me rewrite it again. When is this going to equal 0? Okay. Well, this would equal 0 if the entire numerator equals 0. Because if the entire numerator equals 0, then it would be 0 over something else. So 5 cosine squared of x minus 1 equals 0. Let's solve for x now. Add 1 to both sides. So if I add 1 to both sides, I get 5 cosine squared of x equals 1. Then divide both sides by 5. So where is cosine squared of x going to equal a fifth? And a fifth is the same thing as 0.2. Let's figure that out. We can use our calculator to help us with this. Okay, so in y1, I'm just going to put in here, let me zoom in a little bit. I'm going to put cosine squared. Here's how I have to do cosine squared. I have to do cosine of x, like that, and then square it. That's how you have to put it in the calculator. And you can put a fifth in here, into y2. What I'm looking for is I'm looking for the x value that makes it come out to be true. Okay. So before I hit graph, I'm going to window, and I'm going to go 0 to 10, because that's the x values I care about. And I'll do a zoom fit. So there's the cosine squared curve. And here's the 1/5 curve. Okay. So where do they equal each other? Okay, where do they equal each other? Okay. So here it looks like these two come together at that point, that point, that point, that point, that point, and that point. All right. So how many of those are there? There's here, 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 and here, here. So there are 6 critical values. So the question's only asking me to find how many critical values there are. So that's one approach that I can use to figure that out. All right. That was one way I could figure out that answer. Right. It's not actually asking me for the critical values, it's just asking me how many there are. You could have done this another way. I could have just put the original, let me go back up to the top. I could have put the original problem in. Let me do that. All right. If I put the original problem in here, I have cosine of x squared over x minus a fifth. And again, my window can be from 0 to 10, and then I can do a zoom fit again. I know if the derivative, it gave me the derivative function, when that equals 0, that's going to be a critical value. Okay, so looking at this really complicated curve, figure out all the points where the derivative equals 0, or where the derivative is undefined. Okay. Well, it's continuous on the open interval 0 to 10, so it's not going to be undefined anywhere. But if I kind of zoom in here, let's change the y min to like, I don't know, -1 and the y max to +1. And that's going to change the graph a little bit. Okay, it's going to look easier. So where does this derivative function actually equal 0? Or how many places does it equal 0? Okay, so if I think about this, there, there, there. So if I just looked at this, 1, 2, 3, to me it just looks like there's 3. So is the right answer 3 or 6? Let's make sure that we did the simplification right. All right, let me kind of look at this. What about if this should give me the same curve. If I go my modified 5 cosine squared of x, oops, 5 cosine of x squared, okay. Guys, I made a mistake. And you might have seen the mistake, and I apologize. I forgot to put in that 1x. Okay. Okay. So I forgot to put in the 1x here everywhere. It's okay, everybody makes mistakes. All right, so if I look back at this function, okay, if I look back at the original, 1, 2, 3, I only see 3 critical values. Okay, so f prime of x equals 0 at 3 places, which means that there's 3 critical values. There's 3 critical values. All right, or you could have done it from here. Okay, figure out where this thing equals 0. So if I put that in, 5 cosine of x squared minus 1x. Okay. If I graph using the same window, how many times does it cross the x-axis? Okay, 1, 2, 3. There's only 3 spots. Okay, it just equals 0 in 3 spots. So if I looked at that graph, again, it crosses in 3 places, so there's 3 critical values. So Sorry about that, guys. Made a mistake. Just forgot one letter and it changed the entire answer. Okay. So, sorry about that. So the right answer here was 3. There's 3 critical values. It's just asking me how many. All right. The next question, number 2, it says find the extrema values on this function over this interval. So what they're actually looking for here is they're looking for absolute extrema values. Okay. So what do we know about the extreme value theorem? First off, is this continuous? Okay, let's look at it. All right, let's just look at it. 9 times x squared minus 3 over x cubed. Is that continuous on this interval, -4 to 1? Okay, let's look at that. It should be, but let's just make sure. Zoom fit it. Okay. Is the graph continuous? Here it comes. Okay. You know, it's kind of hard to see in red there. Oops, I want -4 to 1. I should have went -4 to -1. And then done a zoom fit. Okay, doesn't look like there's any gaps. All right. So it is continuous. Would it be defined on the endpoints? Yeah, if I plug in a -4 for x and a -1 for x, I'm going to get an answer out. So what do we know about absolute extrema? Absolute extrema from the EVT, okay, absolute extrema, okay, the highest point and the lowest point happen, okay, on the endpoints or at critical values. Endpoints or at critical values. Okay, so right now I have at least 2 numbers to test. My endpoints, my x values are -4 and -1. But I have to see if, okay, imagine I didn't graph this. Imagine I did not graph this. Okay, let's say this is a non-calculator question. How do I find out if there's any relative mins or maxes? Well, I have to take a derivative. Okay. So let's go back to the function here, f of x, and let's rewrite it a little bit. Okay, it says 9. If I distribute the 9, I would get 9x squared minus 27 over x cubed. All right. So what I have to do now is I have to take the derivative of that. So f prime of x, f of x looks like a quotient. So since f of x is a quotient, I have to use quotient rule to find derivative. Okay, so we say low x cubed, d high, derivative of 9x squared is 18x, minus high, 9x squared minus 27, d low, the derivative of the low would be 3x squared, okay, over low squared. Okay, so if I distribute and multiply, I would get 18x to the 4th minus, okay, I'm going to kind of do 2 things at once. I'm going to distribute the negative and do the distributing here. So negative 9x squared times 3x squared would be negative 27x to the 4th. If I do negative times negative 27, that's positive 27. And positive 27 times 3 is positive 81 x squared all over x cubed squared, power to power, you multiply those, it's x to the 6th. And if I simplify this a little bit, these are like terms, I can combine those. 18 minus 27 is negative 9 x to the 4th. Plus 81 x squared all over x to the 6th. So I'm going to come over here now. Okay, I'm going to take out a negative 9x squared. I'm going to factor out a negative 9x squared. So if I factor that out, I would have x squared left there. Right. And then here, if I take out negative 9x squared there, I'd be left with minus 9. All over x to the 6th. So how can I find the critical values here? Well, critical values happen when the derivative, here's the derivative, okay, which I could actually factor one more time. Negative 9x squared, then x squared minus 9 factors into x plus 3 and x minus 3. And if you make this a little bit nicer, x squared and x6, these two x's multiplied cancel two of these, so you're just left to x to the 4th. Okay, so let me write that on another piece of paper because I know I'm running out of room here. So here's what I get for the derivative. I get f prime of x equals negative 9 times x plus 3 times x minus 3 over x to the 4th. Okay. So let's think about where the critical values are. The critical values. Okay. F prime of x would be undefined when the denominator equals 0. So what number raised to the 4th gives you 0? Hopefully you know right away that's 0. Okay, this is where f prime is undefined. F prime is going to be undefined at x value of 0. Now where is this going to be equal to, where's the numerator going to be equal to 0? Where's the numerator going to be equal to 0? Well, if you think about this, it would be equal to 0 if that thing equals 0. So that would happen if x was negative 3. Or if this thing equals 0. That would be an x value of 3. So at those two numbers, f prime would equal 0. Okay, so these are the three critical values. But let's go back and let's think about our interval. Our interval was we're only looking at things from negative 4 to negative 1. 0 is not in that interval. Okay, so we can eliminate that one. Positive 3 is not in that interval. So the only critical value we have is at negative 3. That's the only critical value there is. So to find the absolute extrema, we got to use three numbers. We have to use our endpoints. Okay. Negative 4 was an endpoint. Negative 1's an endpoint. So these two come from the endpoints. And we also have to think about this other critical value. Okay. Because absolute extrema happen at endpoints or critical values. Okay, so this is the only critical value. Negative 3 is the only critical value. So let's go back to f of x. F of x equaled 9 times x cubed minus 3 over x cubed. We're going to plug in all three of these numbers. So when I plug in negative 4, so that's negative 4 squared minus 3 over negative 4 cubed. And if I simplify that a little bit, I get 9 times negative 4 squared is 16 minus 3 is 13. Negative 4 cubed is negative 64. Okay, 9 times 13 is 90 plus 27, that's 117 over negative 64. And as a mixed number, that's negative 1 and 53/64 as a mixed number. All right. Now let's figure out what f of negative 1 is. So 9 times negative 1 squared minus 3 over negative 1 cubed. So that's 9 times negative 1 squared is positive 1, minus 3 is negative 2. Negative 1 cubed is negative 1. So this would be negative 18 over negative 1, which equals 18. So these are the y values I'm getting out. Okay. Now let's test the critical value. X equals negative 3. All right. So if I plug in negative 3 there, I get 9 times negative 3 squared minus 3 over negative 3 cubed. Okay, so that would be 9 times negative 3 squared is 9, minus 3 is 6. Negative 3 cubed is negative 27. So this would be 54 over negative 27, and that's going to equal negative 2. Okay, so look at these three numbers. Which one is the smallest? Which one's the most, or just the smallest number? That's going to be the absolute minimum. The absolute minimum is negative 2 is the smallest of these three numbers. And that occurs at an x value of negative 3. So this is the absolute minimum value. Okay. The absolute maximum value is, which one of these three numbers is the biggest? Well, the biggest number there is 18. It's 18, which occurs at an x value of negative 1. So, without actually graphing, I found the highest and lowest points on that curve. And I'm just going to use that curve to kind of show you that I'm right here. All right, so here's the two endpoints. At negative, let me hit trace, at negative 4, I get negative 117 over 64. Okay, at negative 3, I get a y value of negative 2, which is as small as it gets. And at an x value of negative 1, I get positive 18. Okay, so that's the high point on the graph. If you kind of think about the graph here, the graph kind of looked like this. Okay. It looks like this, and then it looks like that, and then it comes up. Okay. So that high point is 18, the low point's negative 2. The low point happened at negative 3, the high point happened at negative 1. The high point itself was 18, the low point itself was negative 2. So we could have, I wanted to show you all the calculus that it takes to actually figure out what the high point is on the graph and what the low point is on the graph. But we can do all of that without even looking at the graph. And that's the whole idea. Okay, let's try another one. Let's look at number 3. Okay, number 3. It says what's the absolute maximum value? I want to find the absolute maximum value of f of x equals x cubed minus 3x squared plus 12 on the interval negative 2, 4. That's what I'm looking for. So I know I have to find the values on the endpoints. Okay, first off, is this a closed interval? Yes. Is this a polynomial? Yes. Polynomials are continuous everywhere. So the EVT applies. Okay, so if I want to find out the values on the endpoints, I can just plug them in. So negative 2 cubed minus 3 times negative 2 squared plus 12. Let's simplify that a little bit. That would be negative 8. Negative 2 squared is 4 times negative 3 is negative 12 plus 12. All right. So that's negative 8. All right. And if I do 4, that would be 4 cubed minus 3 times 4 squared plus 12. Well, 4 cubed is 64. 4 squared is 16 times negative 3 is negative 48 plus 12. 64 minus 48 is 16. Okay, so right away, just doing that, what we know already is that when, let me just kind of draw a graph. I have no idea what that cubic looks like, but what I know already is when the x value is negative 2, the y value is negative 8. Okay. And this is not going to be to scale, by the way. And I know when the x value is 4, let's just call this positive 28 up here. Like I said, it's not to scale. Okay. So I know the two endpoints. Okay. Those are the two endpoints. But it might go up higher than 28 in between. It might sink down lower than negative 8 in between here. So the next thing we have to do is we have to find the critical values. Okay, so f of x equals x cubed minus 3x squared plus 12. What would f prime be? F prime would be 3x squared minus 6x. And if you do some factoring, you could take out a 3x of that and you would get x minus 2. Okay. Well, this is another polynomial in either form. Okay, it's a polynomial. It's never undefined. There's no fraction there. But it could equal 0 in certain places. Where would it equal 0? Well, if x was 0, this whole first parenthesis would be 0, so therefore the whole thing would be 0. We're at an x value of 2. So these numbers are possible critical values. Now, are both of these numbers in the interval negative 2 to 4? Well, 0 is inside there, so that is a critical value. And 2 is inside this interval. So that's also a critical value. So now we have to find the y values for these x values. Okay? So now I have to find f of 0, and I have to find f of 2. So if I plug 0 back into the original, that's 0 cubed minus 3 times 0 squared plus 12. Hopefully you'll know right away that 0 cubed is 0, that thing's going to be 0, and that's just going to be 12. What about 2? 2 cubed minus 3 times 2 squared plus 12. Let's simplify that. 2 cubed is 8. 2 squared is 4 times negative 3 is negative 12 plus 12. Okay. So that's going to come out to 8. So on my graph here, when x equals 0, the y value equals about 12, which might be about right there. All right. And when the x value is 2, the y value is 8. Okay. So, don't know what the graph looks like, but maybe it looks something like that over that interval. Right. So it's asking for the absolute maximum value. What is the biggest out of these four numbers? Out of those four numbers, which one of those four is the biggest? Clearly it's this one. Okay. 28 is the biggest of those four numbers, but we had to find them all first to verify it. So 28 is the maximum value. Is the absolute maximum value on the interval -2 to 4. And it occurs at x equals 4. This one happens to be on the endpoint. Okay, actually that point is a relative maximum. This point here is a relative minimum. And I'll prove it to you. I'm going to do this one on the graphing calculator. I'm going to put the original function in here, x cubed minus 3x squared plus 12. I'm just going to look at it from -2 to +4. Zoom fit. Remember, my graph was not to scale. So that's the absolute minimum if they asked for it. The absolute minimum was -8. This relative maximum value was +8. This relative minimum value was +2, and the absolute maximum value was 28. So these critical values is where the derivatives equal 0. So that's a relative max and that's a relative min if they change the question, but not too hard. Okay. This process is cumbersome, but it's the way to do it and make sure we're right. Let's go to the next one. Okay, so number 1 on the back says find the critical points. This is different than critical values. So they want the x and the y because they're asking for points. For f of x equals sine of x, just looking at the interval 0 to 2 pi. Okay. So how do I find critical points? It's just like critical values, but then plugging the x value back in. So the first thing we do is take the derivative. So the derivative of sine is simply cosine. Cosine is continuous everywhere. Okay? It's never going to be undefined. So to find critical values, set it equal to 0. And now ask yourself, at what angles do I get a cosine value of 0? Well, that happens at 90 degrees, which we call pi over 2. Okay, and where else? At 270 degrees, which is 3 pi over 2. So these are the critical values. But they're asking for critical points. So how do I find the critical points? I plug in these numbers to the original function. Okay. So sine of pi halves, that's like sine of 90 degrees, that's going to equal 1. So the first critical point is pi halves, comma 1. Okay. And then 3 pi over 2, it's like taking the sine of 270 degrees, and that's going to equal -1. So these are the critical points. And if you looked at a sine curve, let me graph a sine curve here. That was the original function. And let's just go from 0 to 2 pi. Okay, maybe we'll scale by every 90 degrees. Okay, and maybe we'll just go -2 to 2, that'll do the trick. So here's a sine curve from 0 to 2 pi. Where does it look like the critical points are? Where is the derivative 0? Right there. If I hit trace at pi halves, what do you notice? Pi halves 1 is a critical point. The derivative there would be 0. And at 3 pi over 2, that's also a critical point because the derivative there is 0. Okay? Did this entire problem without using a calculator. All right. The back page, it says for number 2 and 3, determine the extrema. So when they say determine the extrema, they're talking about absolute extrema. Okay. So we're trying to find the absolute extrema and where they occur. So the function on number 2 is y equals 3x to the 4th minus 4x cubed. We only care about that over that interval. Okay. So absolute extrema, we know by the extreme value theorem, it's going to happen on endpoints or critical values. So we already know both of these are x values. That's the left endpoint, that's the right endpoint. You could figure out what the y value is there now, or you could do all 4 at the end, or however many critical values there are. Okay? So let's figure out where the critical values are. So in terms of like what numbers I have to test, I know right away I'm going to have to test negative 1 and 2. I'm going to have to find the y values on the original function. Okay? But there might be other critical values in between. So let's find critical values. Take the derivative. That'll be 12x to the 3rd minus 12x squared. Do some factoring. Take out a 12x squared, and you would just get x minus 1. Figure out where is this derivative undefined. Well, this one's never undefined. It's not a fraction. Okay, and it's not some complicated trig function. So the only critical values are going to be is when it equals 0. So what numbers does that give me? Well, how would we make that thing equal to 0? Well, if x was 0, this whole first parenthesis would be 0. And what number minus 1 would give me 0? Hopefully you say it's 1. Okay. So these two numbers are the critical values. Both of these numbers fall between negative 1 and 2. So here's all the possible locations for the high point and low point, the absolute highest or absolute lowest point in the graph. So now we have to find the y values with these. So let's figure out what y of negative 1 is. Plug negative 1 in everywhere you see an x. 3 times negative 1 to the 4th minus 4 times negative 1 cubed. Negative 1 to the 4th is positive 1. Negative 1 cubed is negative 1. Okay. 3 times 1 is 3. Negative 4 times negative 1 is positive 4. So that's 7. Okay. So I just figured out that. Okay. Now 0. 3 times 0 to the 4th minus 4 times 0 cubed. Hopefully right away you'll know that's 0. Okay. So we know that. What about positive 1? 3 times 1 to the 4th minus 4 times 1 to the 3rd. That's going to be 3 times 1 minus 4 times 1. And that's going to be negative 1. And if I plug in 2 here, 3 times 2 to the 4th minus 4 times 2 to the 3rd. Remember, I'm plugging these into the original. 2 to the 4th is 16. 2 to the 3rd is 8. 3 times 16 is 48. 4 times 8 is 32. 48 minus 32 is 16. Okay. So, it's asking me for the extrema. Which one of these 4 numbers is the biggest? This one. That's the absolute max, and this is where it occurs. Which one of those 4 numbers is the smallest? Negative 1. That's the absolute min, and this is where it occurs. Let's just use our calculator and put in the original function. Let's make sure that's true. 3x to the 4th minus 4x cubed. Okay, I only care about it on the interval negative 1 to 2. So I'm just going to change my x values here. And then I'm going to do a zoom fit. So looking at this curve, where's the absolute highest value? The highest y point, right there on the end, at an x value of 2. So if I hit trace and then type in 2, it goes up to 16. 16 is the maximum value. Okay. Where's the absolute lowest? The absolute lowest happens right there at an x value of 1. And the smallest it gets to is -1. So 16 verified, -1 verified. Okay. So we've solved that problem. Now number 3. Again, we're looking for the same thing. Absolute maxes and mins and where they occur. F of x equals 2x minus 3x to the 2/3. And here I care about the interval -1 to 3. So in terms of the extreme value theorem, okay, first off, this is a continuous curve, and it's closed interval. Okay. So I know I'm going to have to test the endpoints, -1 and 3, but I have to figure out if there's any. Okay. Again, this is an endpoint on the interval, and this is an endpoint. I got to figure out if there's any critical values. Okay. So how do I figure out if there's critical values? I take a derivative. So derivative of 2x is 2. Now the derivative of the next term. -3 times 2/3 is -2. Okay. Reduce the power by 1. So that's -1/3. Now let's write that a little differently. That's like saying 2 over 1 minus 2 over x to the 1/3. Now let's get a common denominator. It's going to be easier for us if we do that. So let's multiply this one by x to the 1/3 over x to the 1/3. Fancy form of 1. So we're not changing the value. Okay. So now let's rewrite it. So now we have 2. What does x to the 1/3 represent? It represents the cube root of x. Minus 2 all over x to the 1/3, which again we can write as the cube root of x. Okay. So that's the derivative. Where is the derivative going to be undefined? It would be undefined if the bottom equaled 0. Well, the cube root of what would be 0? Okay, well, how do you solve that? The cube root of x equals 0. Cube both sides to get rid of the cube root, and hopefully you know that 0 cubed is just 0. So x equals 0 is a critical number. It's a critical value. All right, it's undefined there. All right, so that is a critical value, and it's inside the interval. Okay, now when is the derivative going to equal 0? It equals 0 if the numerator equals 0. So 2 times the cube root of x minus 2 equals 0. Okay, let's add 2 to both sides. So 2 times the cube root of x equals 2. Let's divide both sides by 2. So now I get cube root of x equals 1. Now let's cube both sides. Okay. So hopefully you know that 1 cubed is still 1. So 1 is a critical value. So there's 2 critical values here. The derivative is undefined at x equals 0, and the derivative equals 0 at x equals 1. Now, how am I going to actually find these y values? I'm going to plug all of these x values back into the original. So the original said f of x equals 2x minus 3, but I'm going to write this a different way. I'm going to say the cube root of x squared, because that's the same thing as x to the 2/3 power. So let's figure out what f of negative 1 is. That's 2 times negative 1 minus 3 times the cube root of negative 1 squared. So 2 times negative 1 is negative 2, negative 3, cube root, negative 1 squared is 1. The cube root of 1 is just 1. So that's negative 5. Figuring out what f of 0 is, real easy. 2 times 0 is 0. 0 squared is 0. Cube root of 0 is 0. 3 times 0 is 0. So it's just 0. All right. What about positive 1? 2 times 1 minus 3 times the cube root of 1 squared. 2 times 1 is 2, minus 3 times the cube root. 1 squared is 1. Cube root of 1 is 1. So that's 2 minus 3, which equals negative 1. And find f of 3. 2 times 3 minus 3 times the cube root of 3 squared. So 2 times 3 is 6, minus 3 times the cube root of 9. Now, I don't know what that is without a calculator. This is basically saying what number times itself again would be 9. If that number was 8, this would be 2. Okay. If that was 27, this would be 3. So this is 2 point something. Okay. It's 2 point something. But 9 is closer to 8 than it is to 27, so I'm just going to estimate. I'm going to say it's about 2.1, roughly. 3 times 2 is 6. 3 times 0.1 is 0.3. So this is going to equal approximately negative 0.3. So it's going to equal approximately negative 0.3. So let's ask ourselves, which one of those is the biggest number from, what's bigger, negative 5, 0, negative 1, or negative 0.3? Well, 3 of these numbers is negative. So here's the absolute max value. And there's the x value where it occurs. Now, which one of those other 3 numbers is the smallest? Well, negative 0.5 is. Or negative 5 is. That's the absolute min value. And that occurs at an x value of negative 1. We did that totally without graphing it. Now let's graph it to check it. So the original function was 2x minus 3 times x raised to the 2/3 power. And I only care about this over the interval negative 1 to 3. Then we'll do a zoom fit. So there's what the original function looks like. As you can see, it's continuous everywhere. There is a cusp, but it's still continuous. Okay. So to me, it looks right there at 0. At an x value of 0, that's the high point. So the absolute max value is 0. Now where's the min value? Where's as small as it can get? At the start over there, at an x value of negative 1. The y value is negative 5. Okay. Why were these values, why was 0 a critical value? Because the derivative's undefined there. There's a cusp there. Okay. Why does the derivative equal 0 at an x value of 1? Because that's a relative minimum. Okay, there's a relative minimum there. All right. So here's the process we have to go through to find the absolute high points and low points on a graph. All right. So we're done with that packet. And apologies for the first couple problems. I know I didn't do a very good job on them, but you get the idea. All right, so your packet tonight, packet 33. Okay. In the first two problems, you're just finding the critical numbers. So you're figuring out where is f prime equal to 0 or f prime is undefined. That's your job there. So take the derivative and then figure out where the derivative equals 0 where it's undefined. Okay. Down here at the next problem, it's telling you to find the absolute max and min values. Okay, so we did a couple of problems like that on the back. Okay, for A and B down here. Okay, and on the back of the packet, you have a free response problem to try. Okay, so here it's asking you to find the minimum acceleration. So they're saying absolute minimum acceleration. Here, find the total distance. Remember that total distance is the integral of the absolute value of velocity. That's total distance. Okay. And here, find the average velocity. So to find average velocity, that's like taking the A rock for position. So that's like change in position over change in time. All right, so that's what you're going to do for your packet tonight. And sorry this took a little bit long, and sorry about the mistakes. Just realize that we all make mistakes, even math teachers.